Hello, I'm Tom MacKinnon, Director of Marketing here at Armacell. Welcome to Part 2 of our Below Ambient Systems series. If you missed Part 1, where we talked about water vapor and humidity, please pause this video and go view that one before coming back here. Don't worry, I'll wait for you here. In this video, we'll talk about water vapor diffusion and water vapor permeability, and how these concepts affect your insulation choice on below ambient systems. Water vapor diffusion is the natural movement of water vapor through materials, including building materials. Water vapor moves from areas of higher water vapor pressure to areas of lower water vapor pressure. Water vapor pressure depends on both the temperature and the relative humidity of the air. Therefore, hotter, more humid air will have higher water vapor pressure than colder, less humid air. The larger the difference in these pressures, the faster the water vapor diffusion. To measure the amount of water vapor that passes through a material, the water vapor diffusion coefficient is used, or water vapor permeability. Water vapor permeability is the amount of water vapor, in kilograms, that diffuses through a 1 meter thick layer of a material with a surface area of 1 square meter in 1 hour, with a water vapor partial pressure difference of 1 Pascal. If you watched our What is R value Armacell answers video, you'll notice that this is very similar to how the thermal conductivity was defined in that video, just with heat rather than water vapor. In the USA, the unit perm-in is used to measure the water vapor permeability of a material. The lower the water vapor permeability, the greater the resistance to water vapor diffusion. This property is critical when considering what material to use to protect from condensation on your below ambient mechanical systems. Systems with lower water vapor permeability will have better resistance to water vapor diffusing to the cold surface and, in turn, condensing. Our ArmaFlex and ArmaLight families of insulation products have low water vapor permeabilities at 0.08 perm-in and below, and are the right choice to protect your below ambient systems. In fact, ArmaFlex Ultima, our newest flexible elastomeric foam product, boasts an ultra-low water vapor permeability of 0.02 perm-in, delivering exceptional protection against condensation. As closed-cell materials, both the ArmaFlex and ArmaLight families offer this low water vapor permeability throughout the material. So even if surface damage were to occur, all those cells below the surface would still have this low water vapor permeability, unlike other materials that rely on jacketing or other vapor barriers for this protection. As mentioned in Part 1 of this series, Armacell also offers a calculation tool, ArmaWin, to ensure you have the right thickness of insulation, and installation training, AQuip, to create a sealed mechanical system. All of the things you need to ensure your below ambient system is protected from the effects of condensation. We hope this video has helped in your understanding of this topic, and invite you to subscribe to our channel for even more Armacell Answers videos. And remember, when you have questions, Armacell answers.